Hello Hardchill. Today we are going to be looking at speed time graphs, and we are going to be able to calculate distance from a speed time graph. Your keywords for this lesson are axis, gradient, straight line, distance and change. So here we have a speed time graph. Notice speed is on our y-axis and time is on our x-axis. All we need to remember is if we are asked to find the distance from a speed time graph, that all we have to do is work out the area under it. So if we have a look at this graph in particular, we need to work out the area of that shape. You should be able to identify that that shape is a trapezium. And to work out the area of a trapezium, we would need to add the parallel sides together, times it by the height or the distance between them, and divide by 2. So that will give us our distance. So this is one parallel side and this is the other parallel side. This has a length of 40 and this has a length of 20. Okay? And the distance between them is also 20. So if we substitute all those values into our formula for area of a trapezium, we've got 20 and 40 times by 20 all divided by 2. Which is 60 times 20 divided by 2. And the answer to that, 60 times 20 is 1,200. And divide that by 2, the answer will be 600. So our final answer is 600 meters is covered by the object that is explained, whose journey is explained through the speed time graph. Okay, so let's have a look at this example now of this speed time graph, and it's asking us to calculate the distance. So we are going to now work out the area under this curve or these lines. So if we have a look here, yet again we have a trapezium shape, so we need to work out the area of it. Remember, it's a plus b, i.e. the parallel sides added together, times by the distance between them divided by 2. So the top parallel side, that has a distance of 15. The bottom parallel side has a size of 40, and the distance between them is also 40. So if we plug all that information in, we've got 40 add 15 times by 40 all divided by 2, which gives us 55 times 40 all divided by 2. 55 times 40, the answer to that is 2,200, and then if we divide that by 2, we are left with the answer of 1,100. And remember, because it's distance, our units are meters, because our speed was in meters per second. Okay, so if we have a look at this speed time graph, and there are 4 questions for us to answer about it. So the first question is the car stationary? Now we have to be careful here not to get this confused with a distance time graph, because if this was a distance time graph and there was distance on the y-axis, yes, this car would be stationary. However, this is a speed time graph. So the car is not stationary because it is going at a constant speed of 20 meters per second. So is the car stationary? We would have to put the answer no. Okay, the following question says, is the car travelling towards home? We do not have the information to say if it's driving home. All we know that it's travelling at a steady speed over 120 seconds. So, no. It says, is the car travelling at a constant speed or is it accelerating? Now, we can say that it is a constant speed because looking at the graph, it stays at 20 meters per second the whole way for the 120 seconds. So we can say it's constant speed. It's not accelerating as the speed is not changing. So it's a constant speed. And finally, what is the distance travelled by the car? If we remember that distance on a speed time graph is the area under the line or the curve, all we've got to do is work out the area of this shape. We should know that this shape is a rectangle, so we just need to work out base and height. The base is 120 and the height is 20, so we just have to do 120 times 20, which is 2,400, and that would be meters. Okay, so here is an example for you to try yourselves. It's a speed time graph of Charlotte when she took part in a cycle race inside the velodrome. Please calculate the total distance travelled by her. Once you have done this, please upload a picture to class charts. Thank you.